Hello, my name is AJ Stahlsmith and my presentation is on protein biosynthesis, aka protein synthesis. What is protein synthesis? Protein synthesis is the creation of proteins by cells that use DNA and RNA. This process can be divided into two main phases. The first phase being transcription. This is where a section of protein DNA is converted into messenger RNA. The second phase is when a messenger RNA is read by ribosomes in order to determine amino acids. The ribosomes then accelerate the formation of peptide bonds in order to form polypeptide chains. Transcription and translocation are two equally important and essential for human life. Without these processes, our cells don't replenish and we would die. Past developments. There's a rich history of research. 70 plus years and countless hours of research have been done examining the process of protein synthesis. The first recorded study linked to protein synthesis was in 1951, where they discovered the first protein sequence. The next big breakthrough was in 1954 by the name of Linus Pauling, who had discovered the alpha helix, which is an important basic component to many proteins. He was awarded a Nobel Prize for his accomplishments in the field of study. Then, in 1961, two scientists by the name of Nuremberg and Mattei had demonstrated cell-free protein synthesis. This was an incredible discovery and had paved the way for what we know today as cell-free research. Present developments. Present-day cell-free protein research methods include muscle growth, diet, utilization of protein synthesis, and protein distribution. Some of the biggest takeaways that we have in our understanding would be to the improving strength and improving performance. We have learned recently about protein synthesis and how it's directly linked to performance. Future developments. They are just starting to break the barrier on cell-free protein synthesis research. There is no doubt that creative application will go beyond producing proteins and into fields such as synthetic biology and medical diagnostics. As scientists look into the future for protein synthesis research, they just keep seeing endless possibilities. Protein synthesis chemistry concepts. To understand protein synthesis and how it's created, we must first look at DNA. DNA is a chemical chain made of two long molecules in a spiral. This is what we know as a double helix. DNA carries genetic information that is used in order to grow, reproduce, and function. Another crucial role is mRNA. They are responsible for carrying message instructions from the DNA. The last concept is a polypeptide chain. These long chains of amino acids, otherwise known as proteins, these chains are linked by peptide bonds. Expert roles. No field has occupied more investigators in biology. Nuremberg and Mattei are two names that will never be forgotten in protein synthesis research. Another name that will never be forgotten is George Blake, who discovered that ribosomes perform protein synthesis in cells. He was awarded a Nobel Prize in 1974 for his accomplishments. Positive and negative impacts. Protein synthesis influences our lives every day. As an athlete, it affects my life in a positive way because I worry about maintaining a certain protein intake. This is to make sure I'm allowing my body to get as strong as possible. Another positive impact was business. There are professions that are based on your muscles looking good. Professions such as bodybuilding and fitness trainer. Unfortunately, it's not all rainbows and sunshines. There's a negative side of protein synthesis. Recently, they have introduced perfect proteins. Anytime you genetically modify a genetic core natural process, it can lead to trouble. This is worrisome because protein synthesis errors can produce toxic polypeptide chains, which we know are proteins. In conclusion, the problem with protein synthesis is that it's connected to every part of biology. This also means that there is no limit to the amount of research that is able to be done. At some point, it has become too much information, and scientists have had to decide what they are going to publish and what they are not. Although there is much to learn from studies, they have slowed down. There is less of a need for new information as there once was. Thank you.